Welcome back to The Tech Between Us. We're continuing our conversation about environmental sensors with Ronan Cooney, Head of Product at Ambisense. To catch up on part one of our conversation, visit our Empowering Innovation Together page. Ronan, let's shift gears a little bit and look at more the engineering side of things. When we're looking at indoor air quality, what specific things are we looking at? We've talked a lot about CO2 and VOCs, volatile organic compounds, particulates. Are there specific levels or specific things that we're looking at when it comes to those chemicals?
I think there are levels, and to be honest, Raymond, it can confuse the matter a lot when you start setting different levels for, you say, how many micrograms per meter cubed of PM10 is in it. People's brains explode a lot of the time, you know. That's where you have to have the experts really involved to go, we can do that in the background and we can display to you that this is high, medium or low. And I think that's been a bit of an issue I've found anyway in the industry a bit, that it's too numbers based than trying to just explain to people it's bad, maybe how bad it is on a scale that they can understand, than getting into raw numbers of how many parts per billion of benzene is in a room. Again, people just gloss over and they can't understand it. And it's very hard to keep on top of it, you know. And there was rules and regulations around CO2 levels during COVID. Are we in a pandemic state? There was 1,500 parts per million of CO2 at one stage. There was down to 1,000. Or then I think it went up to 1,200. Being in the space can tell you so much. You go in, talk to the people that are in there. I find it's awful stuffy in here all the time, or it's too hot, it's too cold. Again, it's things that they can feel straight off the bat is obviously really important, I think, to start with. And then look at the conditions. Can you visually see it? Is there mold in certain corners? Is there paint flaking off walls? This is not a good environment to be in. What's the outdoor we talked about already? Are they in a very polluted area? So do they need to make sure, okay, you can't open the windows, or it's worse for you to open the windows. You'll need to get a mechanical ventilation system in place and drive those things on. So I think the engineering part, and that's, I guess, where myself, a product person, needs to merge those two parts together to make sure the engineering is right and the accuracy is correct. And we're doing all that work in the background, but then to transfer that into something that's understandable by the man on the street, that the science is not going to blow them away and you're not going to get buy-in. If you go into a standard office and you're trying to promote indoor air quality and you start talking about PM and VOCs and terms like this alone, they don't know what you're talking about, and it's very hard to get people bought into the importance of it. Then they just think it's too scientific, it's too technical. So there's definitely that level of educating people, definitely to a degree, but then making it very understandable and relatable to what's actually happening in their spaces.
So as engineers, we work in specifications and numbers, the speeds and the feeds and whatnot. And so what you're saying is really, it's actually better than dumping all that raw data on somebody or a decision maker or a stakeholder. Really just describe it in terms of effects rather than pure raw numbers.
Yeah, you need to do that in the background.
Sure.
So like we can take that on. That's where you have to have the expertise and the experience to know what you're looking at. And the regulations can still be driven by that, but not that many people will read a 50-page indoor air quality document that's just been released. They don't get too excited like we do.
Okay, well, I've read one and I know you've read several. So what's that saying?
Exactly. So yeah, like it just needs to be explainable. But yeah, like the engineering work has to go with it, you know, and we have a great team in Ambisense and a great set of engineers, and the technology has progressed so much. Even in the last couple of years, you've really seen it driven on with the sensors and the accuracy and reliability that they have, which is brilliant to see. And that's just continuing. You've just seen it more and more, and driving the costs down again to make the overall unit that we can build much more affordable to people. At Ambisense, really key to us is the data part. We want to provide that data. The customer nearly doesn't need to know about the device or how it works. We can take care of all that. They can trust us to do that, and then give them the output to go, listen, the particulates that you have, basically dust particles, stuff like that, is very bad in this space. You need to look at your carpeting here. It's too much and it seems to be kicking up dust during the day, and then they can action that. So it's, again, giving them something that they can action than just going, you have 200 micrograms per meter cubed in here, and they just fall over.
Is that good or bad?
Yeah, exactly. Yeah, they just don't know. And yeah, that's where you just lose people. And then they go, listen, this whole system's not for us. I'm not interested. and then it's gone and your opportunity is gone.
Right. You mentioned sensors and designing in sensors and how sensors have advanced. When your engineers look at designing a new device or even updating a current device, what sorts of things do the engineers take into consideration when they select a sensor? Is it more of a power thing? Is it more of a size thing? What do they look at?
So yeah, lots of different factors that you can consider. For us in Ambisense, we believe it needs to be wireless. I think as the core sort of version of it, again, just gives you that flexibility within a space, especially if you're retrofitting. So you're in a pre-built office. If you're looking to run wires and power it, it becomes a huge expense again, and then you're not going to win that opportunity. Whereas if you have the battery powered version, you can put it where it needs to be. You pick the best space to monitor it within that room, and taking into consideration things like communication protocols and stuff like that as well. So the best signal coverage that you're going to get. But yeah, like cost and power and performance, I think it's like nearly every electronics device is always the way. You can get a very expensive, highly accurate sensor and put into a device and nobody will buy it because it's going to be $1,000 for each device and it's just too expensive. Yeah, you have to have that balance. But it's been great because you see the sensor manufacturers, they realize this. They know that they're trying to push the cost down on sensors, coming up with new variants, and not at the cost of performance. So the performance is still there. The technology is well established these days. So stuff like NDIR for CO2 sensors is probably the minimum standard really these days. Whereas what we had around COVID time, there was a lot of this equivalent CO2 stuff which was being interpreted from VOC sensors and just wasn't acceptable standard really to give people the data that they needed. So yeah, I think battery life obviously then comes into it. So if you have a wireless device, your cost is at a certain price point, and then how long can you get out of that device? So again, yeah, you need the granularity of data. So you need to look at how long are we going to transmit? How often are we going to transmit? What is the key data that we need? Again, you see some indoor air quality devices and they've 10 sensors in them.
Right.
I think it's probably too many. You need 10. Is there going to be enough information in that to give you more than the core sort of 5 maybe sensors might give you?
Sure.
There was a race, I suppose, at some stage, just go, oh, we've got 10, oh, we've got 12, oh, we've got 15, we've got... and nobody understands a formaldehyde reading or why it's important, So there was definitely a piece on that, I think, of people going too far and companies pushing it too much. And then there was a race to drive the cost down as well. But I think people are seeing now it's the company you really need to be involved with, and what they can give you to make actionable changes. So again, it's not enough seeing a CO2 graph somewhere that it's a squiggly line, you don't really know it's good or bad or what's driving behaviours. And I think the education is increasing now and people are starting to understand it a bit more and want more. And that's really what you want now, is the industry to start pushing it more and people go, okay, I've had these devices in for 2 years now. I know what they're showing me, or I'm not getting value out of this section. Why? What is the important thing about this data? And that's gold dust for product people to get that feedback from customers and develop the new products that will give them those answers that they want and allow them to really improve their environments,
Right. Yeah. Being that combination of you got to be able to have the right sensors and the right IoT sensor nodes in place to be able to collect the data. And then to your point, what do you do with the data on the back end? Taking that and, making sense of it as opposed to, like you said, these raw charts of CO2. And is formaldehyde really a thing that's measured?
Yeah, it is actually. Yeah. We've been approached a few times to try and develop a formaldehyde indoor air quality monitor. So certain environments can be a big factor actually. Yeah.
If Mouser starts putting in formaldehyde sensors, I'm going to start working from home more often.
And the communications is obviously another core one. If you're in a space and you can't get the data out, in our mind, it's pretty useless.
Right.
If it's a display, even on a unit on the screen, all that usually we found is drive fear for people and to go, it's red, it's red, it's red. I better run out of buildings screaming. Yeah. They don't know what to do. There's panic stations. So for us, it should be nearly a hidden sort of thing. It blends into your environment. And then it's up to somebody to manage that. So there's somebody within that space is mandated to, you look after this, you action it, you open windows, simple thing. If the CO2 is going too high, or you see in the meeting room that it's gone very high, knock on the door, tell people, listen, Can we take a break, or can we ventilate the space or open windows, or do whatever? So we sort of see that at a basic level, the monitors are a management tool, and people to manage those space and take ownership a bit more. And again, it's that we spoke about briefly before, is embedding it within the company. So having that policy in place, having the senior management behind it and know the importance of it, and then somebody to manage it in an ongoing way.
With all these sensors, the techniques of sensor fusion have been around for a while. I assume in order to kind of pull that integrated picture together, you guys use quite a few algorithms to integrate the data from the CO2 sensor, from the VOC sensor, the temperature, the humidity, all this stuff into a single combined picture for your customers.
Yeah, it's critical. And again, looking at the most basic level, temperature is a huge driver of so many other factors. In our own office, we had ESD mats on a workbench, so where people are doing soldering for taking the electrostatic discharge and make sure we don't damage the boards. But one of the stations was in front of a window, and we saw basically when the sun was beaming in, that mat was generating a lot of VOCs within that space.
Really? Okay.
So we were able to correlate just something as simple as outdoor temperature, indoor temperature in that space with these spikes of VOCs that we saw there. So again, simple fix. We just moved the mat to a different place, moved the station around, don't put anything near the window. And again, sometimes it's not going to cost 100,000 put in a new ventilation system. It's a very simple thing, but if we didn't have the data there, we wouldn't have seen it. And it's that correlation. Again, one sensor isn't going to probably tell you a whole lot. You have to look at everything in between and what's driving. Is it a temperature issue that the building is generating itself, so the heating system, or is it like solar gain? So what's the temperature and the sunlight outside that's driving that? Yeah, there's so many factors in there that all have to be considered together. And like that's when you're getting into big numbers and big properties, you have to have that machine learning and the algorithms that you were saying in place to manage that data, because I can't sit there and keep correlating between the different graphs. Go, oh, look, the temperature is here and the CO2 or the VOCs are here. So
the time to turn on the big red light.
Yeah, exactly. Yeah. So you need that automation in place. And again, the tools are out there and those skill sets are developing all the time. But yeah, like you have to have the fusion between the different sensors there. It's really vitally important of what's going on. And yeah, like we said before, like particulate is another one of how many people were in the office that day even. So stuff like occupancy, or you could see, say the CO2 is very high in a space. The PM has gone up very high, so you get people moving around, so they're disturbing probably stuff in the flooring, and then you can piece together of what's going on. So the machine learning is a great tool, and it's a hot topic at the moment. ChatGPT and all these sort of things have really put in the spotlight. But a lot of companies like us have been looking at the benefits of AI and machine learning for many years. So it's great to see it. It really drives the industry forward when it does get in the spotlight like that.
Yeah, and throughout of all of our discussions on our Empowering Innovation Together program, we have seen that undercurrent of artificial intelligence, machine learning being used in so many different industries and so many different areas. I was curious, as going into our discussion here today, if machine learning was playing a part, and clearly it is. And it sounds like you guys have been using it for quite a while to really make sense of this massive amount of data that you guys are collecting.
Yeah, big time. And it's things like an anomaly detection. It's a really valuable thing within a space of something. And again, when you're working remotely, for us, say that is there, but something strange is happening here. We can't be on site to know exactly what it is, but at least you can highlight that. And that anomaly detection is really key as well. Something strange is happening in this space all of a sudden, and then they go, oh, we just painted in there. And 2 weeks later, the VOCs are still through the roof. So whatever paint they used maybe was very bad. So yeah, there's definitely huge value, and I think it's rich in every industry and everyone's lives. I think the AI sort of boom that we're seeing.
Yeah, absolutely. And I think we've all played with ChatGPT, at least I have. You probably have as well. Just see what it comes up with.
Yeah, and it's a real valuable tool. Like, I think everyone sees that as ChatGPT. It's a great start, I think, as being the consensus with most people that if you're looking for something, it's a great place to get a start going and get your creative juices maybe going and thinking about certain things. I don't think I build my business on it or trust it to that degree. It's definitely a tool that people will be using more often.
Absolutely. Yeah, we're seeing that as well within our industry. For companies like yourself and people who are working with buildings and other companies to measure and monitor air quality, is there a certification or is there an overriding organization that is governing what's going on out there?
There are bodies out there. So I would say for devices themselves, the very first simple one in Europe anyway is like a CE marking, to make sure that that device is not going to go on fire or something. You know, it's been safety tested.
Probably not a good thing.
You can rely on it. Yeah, because again, like devices were cropping up left, right, and centre. You don't know where they came from. They looked a bit flimsy, no markings, no anything on it. It was a bit of the Wild West, I think, when COVID hit and all sorts of devices came out. So that's always a good first step to look at. But I think Reset is probably one of the most common standards, and maybe people might know that a bit more. It's not perfect, I would say, as a standard. And again, I think all the regulations and standards are improving all the time, and they're catching up a bit more with the technology. They're sort of driving it, and then they're really come together with a lot of the actual building standards and the construction standards. So WELL is another standard that people might know of. You can get your building WELL certified, and as part of that there's a whole indoor air quality section on it, and they're aligned with Reset as well. So that's the sort of hardware and certification bodies coming together, which is great to see. And then you're seeing more and more of the standards like LEED, people might have heard of as well, and Passive Housing, and Energy Sprong is another company that are based around Europe and the UK. And this is just standards of the housing and the insulation. So again, having the data to back up the design that people have built. I know in the UK in particular, they're giving like a 10-year performance guarantee with that house. So if you're going to give that guarantee, you're going to need the data to show that it is achieving it or not, you know, so...
That it's achievable.
Yeah, exactly, yeah. So these things have become more embedded into new buildings and expected by people now. How is the indoor air quality going to be monitored? Do we have energy readings? And again, all automated, that somebody's not having to go and dig through this data, that it's all in one central location is really important. Reset is a great body, and I think it's driving the standards there at the moment. So I think there's other standards sort of cropping up. You see smaller bodies here and there, but if it's one central one that everyone's aligned with, makes the rollout of it so much easier. So hopefully it can kick on.
So hopefully everything harmonizes, especially harmonizing globally, as well as individual specifications and individual recommendations.
And everyone thinks their standard is better than the other person's standard, and we've made improvements to this and that. But just if everyone can align a bit more, the building regulations will drive it really, and what standard they take on will drive everything else, because they're such a big sector, the building and constructions. Yeah, hopefully they can do it.
Let's shift our focus towards the future. Our next question is brought to you by our sponsored partner Honeywell, who is transforming how buildings operate and delivering product solutions for a smarter, safer, and more sustainable world. Explore more from them by visiting Mouser.com/Honeywell. Looking out into the future, however many years, what could benefit most from being more aware of indoor air quality and actually making a concerted effort to improve indoor air quality? And what would you say would be the biggest impact?
I think like that is the construction industry. If they can embed indoor air quality sensors from the very start, and even retrofitting works as well is big, but they're going to be the key really to all of this, that it's embedded from the very start, and they can put these sensors in and maintain them. And the data, we're working already with some construction companies in Ireland around that they're embedding it into those construction projects from the very start. And then they can give a password or whatever to an owner, and they could have their account then, and they can see their own indoor air quality, and they can monitor it and things like that as well. So I think that has to be the biggest industry that's there. But really, it's about people again, and people have to see the value of it as an employer, the spaces that you can give people, that they should be the most productive spaces possible and healthy. People's health is obviously vital and the most important thing, and you need to provide that to your employees and your customers. And again, like I said earlier, I think it's not really acceptable to say I didn't know about it anymore. The technology is there now, so people have to step up and really implement it.
Interesting that you bring up construction, because literally making indoor air quality systems as ubiquitous as power and data. Every building has about a bazillion Ethernet connectors in the walls, and making the indoor air quality system kind of an integral part of that whole building.
Yeah, exactly. It's like smoke detection, but it should really be seen just at the same level. You probably need more granularity maybe, or maybe not with indoor air quality, depending on the building type or whatever, but that's how important it should be, to people. Like, it's not going to impact you today, but if you're working in that environment every day for 10 years within a company, that building is definitely going to have had an impact on your long-term health. So, it's good that people should know that, and it should be very plain to see for employees and customers.
Absolutely. Thank you for listening to this episode of The Tech Between Us. To dive deeper into environmental sensors and explore Mouser's rich content on this subject, visit our Empowering Innovation Together page for videos, technical articles, and more at mouser.com/empowering-innovation.
Providing industry-specific solutions for engineers worldwide, Honeywell's broad product portfolio addresses the world's toughest challenges, delivering products and applications ranging from aerospace defense, industrial, medical, transportation, and more. Visit mouser.com/Honeywell.